All right, guys, welcome back to Robotics 101. So this is your first online asynchronous lecture. So we're going to be talking about how to power on and jog a robot. So the goal today is that you're going to be able to power on a robot, FANUC, and ABB after this slideshow. You're going to be able to explain the differences between T1, which is what we commonly refer to as teach mode, T2, and auto modes. You should also be able to explain the 4 different jogging modes that you'll be utilizing in the lab. And you should be able to demonstrate the right hand rule and be able to create both FANUC and ABB programs and be able to save and upload them. So first we're going to start off with how do we want to power on a FANUC robot. So the FANUC robot has 2 primary methods of powering on. One is called a cold start and the other is called a controlled start. So a cold start is your standard most common method of powering up the robot. Basically it consists of either turning the disconnect on and or possibly pressing an on-off button on the operator panel. Operator panels are more commonly found on the larger B-size cabinets and the I cabinet versus the mate cabinets just have a disconnect you have to turn on. A controlled start is specifically used for booting up into a file backup and software update screen on the FANUCs. So that's where you're going in to do that. Basically, when you turn on the robot, just like you would with a cold start, while it's powering up, you will have to hold down the previous and the next keys on the teach pendant, and that takes you into that controlled start mode. Like I said, that's where you're going to be doing file backups or file recoveries. You would be doing software updates for the FANUC robot. If you buy software options, like you're adding networking to it, like Ethernet IP, that's where you have to put in what's called a PAC code in order to be able to unlock that feature on your robot. We'll primarily be doing cold starts. Really, you shouldn't do a controlled start unless you know what you're doing, because that's one of the ways where you can actually brick the robot. So the ABB robot, unlike the FANUC, only has one primary method of powering on, and that's simply flipping the disconnect on. None of the ABB robots on the IRC5 controller have an on-off button in addition to the disconnect. You simply turn the disconnect on. The robot's going to start booting up. You'll see a little loading bar pop up across the teach pendant as the teach pendant connects. You're just flipping it to that on or that 1 position, depending on how the disconnect is labeled. 1 just means on, 0 means off. Unlike the FANUC, if I want to do software updates or anything like that, a lot of that stuff is done through the use of ABB's Robot Studio software. So let's talk about teach versus auto mode. So teach mode, or what's called T1, that stands for test mode 1. So in this teach mode, you can use the teach pendant to create and test new programs. The robot's going to be limited to a Cartesian speed of 250 millimeters per second and 10% of the joint speed. So that's the thing we talked about when we were talking doing our safety presentation a couple weeks ago. So in this mode, it is generally safe to enter the work cell with the robot if you are in possession of an enhanced enabling device or a dead man switch. So basically, this is the mode where you can pick up the teach pendant, walk into the cell, and be programming the robot, making new programs, doing touch-up work, whatever it may be. If you need someone else in there with you, that you should also have a dead man switch or an enhanced enabling device on them as well that controls your robot. But only one person should have control of actually jogging the robot. We then also have a mode called T2, which is referred to as test mode 2. So in this mode, your jog modes will be limited to 250 millimeters per second or less, just like your standard teach mode, or T1. But the difference here is that program playback speeds are at full speed of the robot's capabilities. In your T1 mode, your teach mode, not only is your jogging speed limited, but your playback speed is also limited. So T2 mode, so that might be used for something like if we're dealing with sealing robots or painting robots where I need to test the program at full speed. But the problem you run into there is with T2 mode, you have to have all the work cell safety in place prior to using. So for example, like you don't want to be inside the work cell when a robot's in T2 mode. So that's where you want to be outside the work cell just like it was in auto mode. Basically, if the robot's in T2, you want to treat the robot like it's in auto mode. So let's talk about what auto mode is then. So in auto mode, the robot is going to operate at a specified maximum speed, whatever that robot is capable of. You are unable to start programs using the teach pendant, so I can't just walk up the pendant, hit the play button, stop buttons in order to get it to run, or the forward, backward buttons on the FANUC. This mode is going to require all the work cell safety to be in place prior to using, so we need to make sure we got interlock switches on the doors, all my e-stops are functional, all of that wonderful safety stuff we talked about. So auto mode is where the robot is basically going to run automatically. The PLC is going to trigger it to run. PLC being a programmable logic controller, it's the thing that coordinates multiple arms in a larger work cell system. So there are 4 primary jogging modes, and those consist of joint, world, tool, and other, primarily user and jog frame. Other than joint, all of these jogging modes are going to move in a linear fashion through a Cartesian coordinate system, or it's going to reorient around a Cartesian coordinate system's axes. So what that means is a Cartesian coordinate system you're actually very familiar with. If you've taken any math classes where you've done graphing, where you're dealing with that x comma y positioning, that's all Cartesian points. So basically our robots are saving all of their locations based on an x, y, and z position in space, a Cartesian coordinate. So world, tool, user, jog frame, all these different modes. These are all jogging the robot through those Cartesian coordinates. And when we say linear fashion, that means as you jog it, it's moving in a straight line, or it is reorienting around one of the X, Y, or Z axes that are created through the use of our different coordinate systems. Joint mode is the only jogging mode that does not do this. And in joint mode, we're going to be moving each joint individually. So let's talk about what is joint mode. So as I just stated, joint modes, you're going to move each joint individually. So as you can see here with this little picture of this yellow FANUC, I've got J1, J2, J3, J4, J5, joint 6, all labeled. Basically, I'm going to be moving each one of those individually. So if I wanted to select this mode on the FANUC, I would press the coordinate key until I see joint appear in the top right corner of the pendant screen. From there, I can then use my plus minus X, Y, Z, rotation around X, rotation around Y, rotation around Z keys in order to jog the different joints. And it basically works its way down those different jogging keys of joint 1, plus or minus, joint 2, joint 3, joint 4, joint 5, joint 6. To select that mode on the ABB, you can press the axes 1 through 3 or the axis 1 through or 4 through 6 key. That's in the middle of the 2 white keys. That's the bottom one. The top one is going to control between your Cartesian systems and your linear reorient modes. Now, something to think about with joint mode is because we're moving each joint individually, that doesn't necessarily mean that it has to be a rotary joint. So, for example, on a Cartesian robot or your robot with your square work envelope, so that robot uses 3 orthogonal linear slides in order to drive each of the joints. Each of those are still a joint. So if I were jogging in joint mode with a Cartesian robot, I would actually have a linear motion versus a rotary motion like I would with my articulated FANUC. So let's talk about world mode. So world mode allows you to move the robot in reference to a Cartesian frame. World is the default frame for the system and cannot be changed. World is also the default reference for all other user-defined frames, which we're going to get into a lot of user-defined frames once you get to Robotics 2. But for now, we're going to be sticking with world. So in the case with FANUC robots, the world origin is found at the intersection between the centers of joint 1 and 2, whereas with ABB, the world origin is found at the center of joint 1 and the base of the robot. So different companies have a different position for their origins. So with world mode, this is where positive X is coming out of the front of the robot. You can easily identify where the front of the robot is. If you look at the base of the robot, you find where the cables come out the back. That's the back of the robot. So positive X should be coming straight out of the other side of that base. From there, positive Y should be to the robot's left, and positive Z is vertical. So world is probably one of the most common modes that people jog the robot in because it doesn't change. It's very easy to identify which way the robot's going to move when you're in world mode. And we can do that with something called the right-hand rule that we'll talk about in a few slides. Then we have what's called tool mode. So tool mode is a method of jogging and rotating around the tip of the tool, or what's called a tool center point, or TCP. The default point of origin is the center of the tool plate, with positive Z pointing straight out of the tool plate as shown here. So unlike world mode, where even if my tool changes orientations in world, if I'm jogging in world mode, that tool is just going to keep going up, down, left, right, forward, backwards based on my world axes. But with tool mode, I've got my axes instead attached to my tool plate for now. And when I'm jogging the robot, if I change the orientation of my tool plate, I get to change the orientation of my tool axes. What this means is this can be really beneficial when I'm trying to teach positions when I'm going in and out of like a slanted object or things like that. Let's talk about the other types of jog modes. So the other types of jog modes that are primarily used are what are called user frames or work objects, jog frames, and base frames. These are all frames that we're going to discuss in Robotics 2, but for now they're all going to resemble world mode. Basically, user frames, work objects, jog frames, base frames, these are all ways of redefining kind of like a secondary world mode almost. Like I said, we'll get way more into that in Robotics 2 than we will right now in Robotics 1. So for now, just these three modes, you can basically just assume they're world mode. If you ever have a question like the robot's moving weirdly and you have one of these on, just grab me or grab myself or Andy or whoever, and we'll gladly help you with that. So let's talk about that right hand rule thing I mentioned earlier. So Cartesian coordinate systems all use a standardized XYZ axis relationship. So, and basically the way that works is that your X, Y, and Z axes are all perpendicular to each other, and they're always in the same orientation relative to each other. So the right hand rule is a common method of representing that relationship using your thumb, index, and middle fingers. So to quickly identify something like the world axes, we can locate the back of the robot where the cables come out and point my index finger towards the robot, my thumb away from the base, and my middle finger should be perpendicular to my index finger as shown in this picture down here in the bottom right. And that shows me the robot's positive X, positive Y, and positive Z axes for world mode. If I wanted to identify them for tool mode, assuming I'm using my default TCP, like mentioned earlier, basically you can take your thumb, put your fist on the bottom on the tool plate. Your thumb should be pointing away from the tool plate, so that shows you positive Z. Then if you were to jog the robot in either X or Y in tool mode, you'd be able to align rotationally your index finger and middle finger, at which point you would then know which way X and Y are. Most commonly, though, it's really handy mostly for Z for going in and out of things. A common rule of thumb for tools is positive Z is going to take you closer to the object, and positive X is going to bring you nearer to the object. It'll make more sense in person as we get into the tool center points next week. But so let's talk about how to actually select these different jog modes. So to select any of the jogging modes on the Fanuc robot, all you have to do is simply press that coordinate key until the desired jog mode is displayed in the upper right hand corner. So as you click that coordinate key, it's going to transition between joint, world, user, all those different modes. That coordinate key is found fourth from the bottom, just to the left of your position of your jogging keys here, and it just says COORD for coordinate. Make sure when you press this key to change jogging modes, you're not pressing the shift buttons. If you press the shift buttons, you get this jogging menu that pops up for selecting different frames. If that happens, just hit the previous key, it'll go away, and then just click the coordinate key to switch your modes. We'll get more into how that mode and more to what that menu does next week. But so all you gotta do is press coordinate key to select your jogging mode. You can also adjust your jogging speed by pressing the plus and minus percentage keys that are found directly under the coordinate key. This is going to let you directly control the speed that your robot's jogging at. This is really important because on the Fanuc robot, we just simply have push buttons instead of like the ABB where I have an analog joystick. So what this means is if you have that robot 100% and you hit that X positive, that robot's going to move as fast as it can in teach mode in X positive or joint 1 positive, depending on your mode. So when you're getting really close into a fixture to pick your parts, things like that, it's really important to slow down your jogging speed so you can get a more precise jogging mode so you can more precisely line up your parts, line up your positions to save them. Some other things to note about jogging the robot on the Fanuc is if you want to view the robot's current position or the joint values, you can simply you can press the menu key on the teach pendant. And then if you go to the next page, you will either see position or you'll see 4D graphics. The older robots just have position. You click that position and it will bring up a little screen where you can then use the F keys to change between viewing things like the joint, the world, the different mode coordinate systems. If you see 4D graphics, you just have to go into that menu and then select position display for the same display. ABB's got a little more complex though. So there's a couple different methods on the ABB to allow me to select different jog modes. So let's talk about method 1. So this is probably the most common one you'll use while teaching. So with method 1, we can change between linear and reorientation by simply pressing this linear reorientation key. We can then also open up the quick set menu, which is the little menu found at the bottom right corner of the touch screen that usually says ROB1. But from here, we can then select the robot that'll pop up in the top right corner. And this will then show us the little jogging window. And we can then press show details to have more advanced options. With our showing details, we get this more expansive view where I can now control things like my jogging speeds. I can select whether I'm in linear or reorientation modes. I can also even select between my two joint modes. So where you see 1 through 3, 4/6. 1 through 3 is going to control joints 1 through 3 with the joystick. 4/6 is going to control joints 4, 5, 6 with the joystick. If I'm in linear reorient, I can choose whether I want to jog based in world-based, tool, or user frames. For us, we're going to be mostly dealing with world and tool for now. Method 2 is I can click on the ABB menu, which is that little hamburger looking menu in the top left corner. We can then go and open up what's called the jogging window. So from the jogging menu, I can choose a motion mode, whether I want to do joint for joints 1 through 3 or 4 through 6, or if I want to choose linear reorientation modes. From there, I can then select my coordinate system if I'm choosing linear reorientation. I can choose between world, base, tool, and work object, just like we had before. Another thing that's really nice about the jogging menu versus just the standard quick set menu is that with the jogging menu, you can actually see the direction to move the joystick for positive movement for whatever mode you're in. So for example, here's just a quick snapshot where it shows that if I move the joystick down, the robot's going to move in positive X. If I move it to the right, it's going to move in positive Y. And if I rotate the joystick counterclockwise, it'll move in positive Z. And then you can see up here, I've got the position the robot's in relative to, in this case, what's called the work object. You can set that to world. If you're in joint mode, it'll actually show you the joint values here instead of X, Y, Z, Q1, 2, 3, 4. Q1, 2, 3, 4 is what's called quaternions. It's another way of displaying rotational data. So let's talk about how to create a program and a routine. So on the ABB, we want to know how to create a module. So a module on the ABB, you can think of it kind of like a folder on your computer. So that module is going to contain all sorts of data. It's going to contain things like your positions, your offsets you're going to create, your variables you'll be creating, and all your different little routines that you're going to be creating. So the big difference with ABB is a module is like a folder. That's what we like to store and save to our thumb drives versus something like a routine, which is actually the set of commands that you want the robot to run. So to create a module, you open the program editor. So from the menu, you open the program editor screen. You'll then see a tab on the top that says modules. You want to click that, at which point you then have a file option in the bottom left corner. If you click that, you then can click new module, and you can then name the module whatever you want. So for example, I recommend your initials, then the lab number. So for example, for myself, I would name it SM Lab 3, and I want to make sure I choose the type program. That's going to allow us to store those routines and allow us to store those lists of commands we want the robot to execute. From there, I can then select my module and click Show Module, and that'll then let me go in and start creating routines and things. So to create the routine, once I've hit Show Module, I can now select the Routines option. Same thing, the routines you'll find just to the right of that Modules tab from before. We'll go File, New Routine. From here, I can then name the routine the lab number, for example, or a subroutine name, whatever it may be that I'm trying to do. I make sure I select my module. If you do not select your module when you are doing this, what will happen is your routine will get stored somewhere else. So if you save your module, you won't get that list of commands you want the robot to execute. And that means if you don't finish your lab, you're going to be restarting next time you come in. So make sure you save your routine to your module. For now, we'll leave all of their declarations at their defaults. We'll talk more about what those declarations mean as you progress through this program. From there, you can select your routine, click Show Routine, and you'll see this little bracket, SMT bracket. This is basically you select that in order to start adding instructions. And Lab 2 is going to take you through how to do that. So on FANUC, we have programs that we create in order to, is what Well, FANUC calls programs, basically that's your list of commands that you want the robot to execute. So to create a program, I go to menu and then the select screen, at which point I can then choose create, or you can press the select button directly on the teach pen to go right to the select screen, and you can then press the create key, which will be a F key. On the top of it doesn't show in this picture, but at the top of the teach pennant, you've got that F1, F2, F3, F4, F5. Those are what are called soft keys. And basically where you see these 5 gray boxes on the pendant at the moment, those will populate with different commands that they can be in order to, depending on the screen you're on, or different features or functions depending on the screen you're on. They're what are referred to as function keys or soft keys. So I go menu, then I'll choose the select button, and then I will press the F key for create. I can then name my program. So for example, I'd recommend doing the same thing. Name it your initials, underscore lab, and then the number. From there, you can then select edit, which is usually the F3 function key in order to create the program. And from there, that will take you into the editing window, which will then let you start modifying and generating a program and generating that routine. So sometimes it's really handy to be able to save and upload a program. So for example, if you're running out of lab time and you want to save your program, or you want to go through and you've saved your program, you're coming in on Saturday or something to get caught up, whatever it may be, or the next class period, and you want to upload your program back into the robot so you can keep working. So we need to know how to do that. So on an ABB robot, it's pretty simple. We're going to go back into that program editor and go back to that module tab. From there, we can go file, and we've got the option of save module as. We then press the file up button, which is this little folder with an up arrow, until you'll see what says HD0A. And if you've plugged in your USB, you should also see your USB drive. HDOA, that's the hard drive on the controller. That's the controller's memory. So if you want to save it to take it with you, you want to save it to your USB. From there, you'll select your USB, then you can choose whatever folder you want to save it into and click OK to save it. If you're loading a module, we'll do the same thing. We're going to go into the program editor screen. You're going to go to that module tab and go to file, at which point you'll then click the load module. Same thing, you'll press that file up button until you see your USB drive. You'll select your USB, choose whatever folder, wherever that file is hidden, is stored away at, select the module, press OK to load it. Nice and simple. FANUC is a little more complicated. So with FANUC, in order to save or upload a program, we first have to set our device to our USB drive. This is for the newer FANUC robots that all have USB devices. Sadly, our older FANUC robots require a more complex system to save. It's known as K-floppy. So for now, we will not be saving our programs off the FANUCs. But to save your file off of a newer FANUC that has USB, you can go to the menu and you'll choose what's called File, at which point you'll then press the soft key for File, and you will then select the utility and set device. If your USB is plugged into the controller, you choose UD1 for your device. If your USB is connected to the teach pendant, you would choose UT1. You can then select the ** for all file, and that will show you all the files that are on that USB drive. So if I wanted to upload a program from there, I could then select that file menu and select either the TP or LS file that I wish to load, and I can simply press the load key right from that file menu. The load key is the F3 function key. So TP and LS files, let's talk about that for a second. So a TP file is FANUC's encrypted file that stores your program data. It is encrypted and can only be read using what's FANUC's RoboGuide software or by another FANUC robot. An LS file is what's called a list file. These are text file copies of your program and position declarations. So this is an LS file is a way for you to be able to print off your program or to modify it in a text editor. You can only upload an LS file back into the robot if that robot has the ASCII option. ASCII is the system of characters for how we type on keyboards. Basically, the robot has to be able to read the ASCII characters from the text document and convert it back into the TP file. So that is a software option you have to purchase separately. So if I want to save a program, we're going to want to save both of these, the TP file and the LS file. So to save it, after I've selected and set my device as my teach pendant, as my USB on either the controller or the teach pendant, I'm going to go back to that select screen. From there, I'm then going to find my program, and I can then press the next key in order to change what those function keys do. And you should see copy, detail, load, save as, and print. If you choose print, which should be F5, this will create the LS file on the active file and device. So that's why it's really important that you make sure that you set your device prior to doing this saving process. Then, if I want to save the TP file from that select screen, I would then choose Save As, which is F4, in order to copy the TP file to that active file and device. From there, I can then choose the directory as well, and then you press Do Save in order to save that file. All right, so that's been an introduction into jogging the robots and creating some programs. If you have any questions, please feel free to reach out to me and let me know. And I look forward to seeing you guys in the lab to work on how to jog a robot and create a program. All right,